Hello, this is TelecomTV. I'm Martyn Warwick. We're here in San Francisco, in California, in the United States at the Data Plane Development Kit event 2014, DPDK for short, and I'm talking with Jim St. Ledger, Software Product Line Manager at the Communications Infrastructure Division at Intel. I think I've got right, Jim.
You got it exactly right, Martyn.
Great to see you again.
You too.
Lovely to chat with you. Let's begin at the very basic level, shall we? What is DPDK?
So DPDK is, of course, my favorite acronym, and the more times you say it, the better you get at it. As you mentioned, stands for Data Plane Development Kit. It got created, the embryonic stage usually was in roughly 2005, 2010, and then we put our first release out there in 2010. But what it really is a software library that lets you do packet acceleration on general purpose processors, Intel architecture x86 processors. In the days before that, and sort of what does it sort of replace or why did it come to exist? There's lots of people out there doing dedicated pieces of silicon, whether they're ASICs, network processors, communication-specific processors, et cetera, that are typically single function and can do that function very well, but then don't give you any flexibility or capability for additional functionality. And DPDK is designed to let you bring those communication workload packet processing functions onto a general purpose processor and then use additional cores on a multi-core processor to take care of other things, whether it's control plane or application workloads or what have you.
Okay, Jim, so that explains why DPDK, keep saying it,
very good,
is important. But why is it particularly important right now? Like SDN, like NFV over the past couple of years,
right.
They seem to have sprung fully formed from the ether. They just weren't there and then suddenly they are.
Yeah.
Is DPDK the same?
Well, it's not the same, but it for sure is related. So, let's go back to what you've been hearing now for 3 to 5 years, and that's the explosion of mobile devices combined with the explosion of data, combined with the explosion of video and social networking and everything else, right?
Yep.
These things, of course, are happening on mobile devices more than they are on larger clients or fixed devices like a desktop computer, perhaps, right?
Sure.
And, of course, with that comes all the traffic going out to the service providers and carriers and the telecom networks. And then the problem, of course, of the over-the-top elements, and are they not going to get paid for it, et cetera. So they've got this big problem that isn't going away and is only getting worse. So they're now saying, how do I fix this problem of declining revenue, ARPU is going down, how do I deploy services faster to try to capture some of that revenue, and how do I manage this traffic? So out of those things have sprouted things like SDN and the cloud and data center, of course, and things like network functions, virtualization, and the telco infrastructure. Now, if you look at let's call it the promise of NFV in my own words. The promise of NFV is to be able to take all these different types of network elements on dedicated boxes and move them to standard high-volume servers in a virtualized fashion. So your functions run as a virtualized function now on a standard high-volume server box that presumably might be more cost-efficient and more flexible and scalable. Now, the question then is you start drilling down a few layers. So at the top layer, that story sells really well, sounds terrific, everybody wants it, right? You saw in October 2012 when the white paper was written, it's the who's who of the telecom service providers worldwide, not just in any one geography, all signed on.
Sure.
So then you get into okay, great idea, how are you going to do that? So you go down a few levels, and that's where my world comes in.
Right.
So this is exactly where things like Data Plane Development Kit or DPDK play in. They take care of that data plane element and the packet workloads and let you move those from these dedicated boxes and dedicated ASICs and dedicated network processors that are awesome at single functionality and now move them to a box that has multi-functionality and can run efficiently and effectively in a virtualized environment.
Great answer. Let's talk open source for a second. DPDK is generally regarded as being sort of intimately entwined with Linux. We've heard of open source projects or allegedly open events and open programs in the past. Sometimes they are, sometimes they're not. Is DPDK an actual open source project, or is it basically proprietary with a few open source editions bolted on here and there?
Right. So let me start with what the software experts I've spoken with give me as the definition of an open source project. Because I'll say before those conversations I had my own. But their definition is if you have something that's GPL or BSD licensed, by default it's an open source project. Now, and it's open because the people that are using it or you're giving it to, because of that license, are free to go use it as they want. And DPDK we specifically licensed as BSD to give that flexibility. And we are regularly told by everybody from telco equipment manufacturers to data center and cloud folks that are using DPDK that BSD licensing is a fundamental enabler for them. They don't have to give anything back. They don't have to tell anybody what they're doing. They can take it and run with it as they like. So that's sort of, let's call it the formal definition of open source. Right. BSD licensed, absolutely. Now the flip side of that, of course, is, well, is it just Intel or other people involved in it? And for sure, in the incubation phase, it was just Intel. I would argue that any open source project, no matter what, always has someone who starts it. Go look back at, Open vSwitch. Go look back at OpenSSL. Go look back at Open Daylight. All of them have someone who's, let's call it the instigator. That's how things come to be, right? And then they bring in their friends, let's say. What DPDK has done started out by Intel as an open source project, and now has turned into an open source community. And with the creation of a community is when you can start expanding things. And so 6Wind, to their credit, helped us kick off that community, and they're the ones who are currently hosting dpdk.org, and they also have a person who's the dpdk.org maintainer. And that now lets many other people start contributing. So that site launched in March 2013, and since then we've had, I think, 60-ish individuals from a half dozen or so different companies contribute the 600 or so patches to DPDK at this point. So at this point in time, 100% open sourced. And I'll also add, of some of those contributors, those folks who are ranking and grading semiconductor companies will look at a few of the names and say, well, at least a couple of those guys are competing. So this is the classic open source story where you may compete on the sales side and you'll collaborate on the community development side.
Moving forward a bit, does DPDK provide functionality like firewalling and IP security? Because as I understand it, it's been described to me today as a fairly primitive, low-level sort of system.
Right. So the DPDK really is trying to work at the lowest levels of what it takes to receive and transmit a packet.
So it's a sort of lowest common denominator.
Exactly right. So we're looking at, what are the things bringing packets in, making them available to whatever you want to do with them. Do you want to do deep packet inspection? Do you want to set up a stateful firewall? Do you want to do some kind of pattern match, et cetera? And then when you're done with that, what are you going to do to send your packets out?
Right.
So we're trying to do the enabling of those, and of course also making sure it's tuned and optimized for virtualized implementation. So you'll get these firewalls and IPS systems that are virtualized network appliances, right? So we're trying to be supportive of them. And that's really sort of we view ourselves as a fundamental enabler of things like that.
What about practical implementation then, Jim? What are the models? How easy is it? And are there many big challenges?
So from a practical implementation, we have something in DPDK that I've dubbed the 3 Cs. And the 3 Cs I call are concepts, code, and commercial. So I'll walk through each of them. The concept side being the first one is really the way we go about doing things through the DPDK libraries, the memory management, the poll mode drivers, et cetera. And we've, of course, our documentation is fully transparent, again, because it is an open source project. It's all posted in the community, as is the code. So if you're someone who's got years and years of legacy networking software, you've got your own proprietary stack perhaps. Perhaps you even have your own proprietary operating system. There's certainly a few big TEMs out there that still do, right? And will for years to come, because moving from that is very painful to do. You can look at what we did, see the efficiencies where we gained them, and implement those ideas and concepts in your own domain. So that's the concept side of it. The code side of it is looking directly at our libraries and saying, I'm going to take your libraries out and plug them into my own world. They may plug in one-to-one. They may require some work on your side to do. But often it's a very good savings for you as a software developer working at an equipment provider to plug those in directly. So that's the code side of it. And the last one is the commercial side of it. And the commercial side would be, so I love the acceleration, I love the efficiency, I love the scalability and impact it gives me by bringing my packet workloads onto an Intel architecture server. But I don't have a staff of software engineers that can go and do that myself. Where can I go and buy this? And this is where people like 6Wind and Tieto and Wind River and CalSoft and others come in. Right? 6Wind, for example, has a full networking stack called 6Wind Gate. It runs right on top of DPDK. And you as a customer could go buy that as a turnkey commercial solution and be up and running with a software-based packet acceleration solution in a very, very short period of time. And as we know, time is money. So are you going to pay for software engineering resources and dedicate your heads that way, or are you going to buy a software product? That's the flexibility that's provided in the DPDK approach.
Great explanation of DPDK. Best I've heard so far. You know this stuff anyway, Jim. Great to see you again, as I say. Pleasure. Thank you very much indeed.
Martin, thank you. Hope to see you again soon. Thanks.